To start the study of linear algebra, we will start with vector. In this section, I'll first introduce to you what is a vector and why do we introduce the concept of vector. It is necessary to study linear algebra because it has expanded our mathematical research from studying only one number to a group of numbers. This will be very convenient for us to express the multi-dimensional world we live in. So how can we express a group of numbers? The answer is actually vector. You can simply understand that the so-called vector is just a group of numbers, and we have a group of numbers which has a bracket around it, and we use comma to separate each numbers. For example, such a group of numbers actually contains two numbers, namely 4 and 3, and then they form a vector. Usually we call this a two-dimensional vector. What is the use of studying a group of numbers? In fact, a basic starting point of vectors, the basic starting point of a concept of vector is that we can use a group of numbers to better represent the directions. For example, we can imagine that in a two-dimensional plane, we start from one point to another. And then in this process, I can use such an arrow where the starting point is here and the ending point is here. If the distance between the starting point and the ending point is 5 kilometers, if I walk the same 5 kilometers and start from the same starting point, but I would probably reach a different ending point. Please note that in this example I have walked 5 kilometers, but the final destination is not the same. So only use the number 5 is not enough to show where I finally reach. Then the vector has its meaning. As you can imagine, I can draw a two-dimensional coordinate axis for this process. So for the first process, I walked 4 kilometers in the direction of x and 3 kilometers in the direction of y. And for the second process, I walked 4.6 kilometers in the direction of x and 1 kilometers in the direction of y. So for the position of our first endpoint, we should express it as a point of 4, 3. And the position of the second endpoint can be expressed as the point of 4.6 and 1. In other words, I need to use two numbers, and we can accurately express the difference between the two positions. And this is because we introduced the concept of direction. We also start from the origin of the starting point and walked 5 kilometers, but there is a deviation in the direction, so the end point we get is different. In the three-dimensional space, it's the same thing. And we're starting from the origin. There are many different directions for us to move forward. In different directions, we also walked 5 kilometers. Finally, the coordinate point of the three-dimensional world is different. The example I give here is actually an example of displacement in physics. In addition to displacement, the concepts such as velocity, acceleration, force, and so on all have the concept of directions. It is not enough for us to just look at its length. It is one-sided. In order to more accurately see the real physical meaning of these physical quantities, we have to think about the directions. for the convenience of this study, we define the vectors starting from the origin. But let me remind you that for a vector, because it is represented by multiple numbers, the order of these numbers is very important, and this is very easy to understand. Obviously, the vector represented by 4, 3 is quite different from that of 3, 4. In other words, a vector is also a set of ordered numbers. Different orders of vectors represent different vectors. Before this, I've been saying that the reason why we introduced the concept of vectors, in other words, the reason why we use a set of numbers to express some things in our real world is because of the concept of directions. But if we only need to express the physical world, we only need three-dimensional vector. This is because our world is three-dimensional space in our own perception, and visible directions can only be found in a three-dimensional space at most. But in order to expand our research scope and enhance the mathematical concept of vectors, we can use vectors to describe the n-dimensional world. But so many students always tangled about four-dimensional space, like what kind of space is it like? But students should be clear about this concept. We cannot intuitively perceive the four-dimensional space or the five-dimensional space. We can't see it or even draw such a space. We can only understand it in an abstract way. But in fact, we can express a thing with high-dimensional space, which is not a very rare thing. In fact, we often do this. When we describe a thing, we often say that we should describe it from different angles. And these different angles are actually different dimensions. For example, if we want to describe a room or a house, we can depict it from these angles, from these perspectives, like how large is its area, and how many bedrooms and how many bathrooms does it have. And we can also describe how far is the house from the nearest subway stations, and how many kilometers is it, and also the price of this house. So every number here is actually a dimension. Different houses have different numbers, so each house can be represented by such 5 numbers. In other words, we use different 5-dimensional vectors to describe different houses. So this is a 5-dimensional vector. Yes, of course, the meaning of this group of numbers is actually defined by the user. In fact, for space imagination, as we mentioned before, we use vectors to represent the directions. In fact, no matter it is 2 dimensions or 3 dimensions, which dimensions is represented by which dimensions is actually defined by our users. But in any case, we can see that the vectors is an ordered set of numbers. So we can look at it from 2 perspectives. One perspective is just an ordered numbers. One perspective is to see it as a direction. And the other perspective, it seems that it does not mean a direction. It is just an order of numbers. So for this group of numbers, we can understand it as a data point in a high-dimensional space. In other words, you can imagine that for these 5-dimensional vectors, that there is a space with 5 latitude axes, and with 5 latitude axes, and then the starting and the ending point of each axis can be from negative infinity to positive infinity, and any values can be taken between them. And then our current house corresponds to these 5 dimensions, and which are the points correspond to these values. So once we use this perspective, the two perspectives can actually mutually exchange each other, because a directions and a point are actually one-to-one corresponding. And vector, in fact, can be described as row vectors or column vectors. These two terms sound very scary, but in fact they are very simple. The so-called row vector is just a group of vectors which are arranged in a row, and the so-called column vector is just a group of numbers arranged in column. Generally speaking, in the textbooks or papers, once we mention a vectors, we usually mean column vectors. In other words, habitually we prefer to put vectors in columns rather than in a row, even though we read them line by line. So why do we prefer to put the vectors numbers in a column? For the reason behind this, we'll explain this in the following chapters. But in these sections, you will only need to remember this rule. And when we read textbooks, because our books must be printed line by line in order to express the column vectors, sometimes we use such a symbol. We first write the vectors into a line, a row, and then write a T in the upper right corner. That is a transpose operation. Well, that's all for this section. Thanks for watching, and in the next sections we'll introduce some basic operations of vectors. I hope you will like it.